Alrighty, folks, welcome back to the second conversation today, looking at research coming out of the Faculty of Arts and Science. We're so pleased that you could join us online and in person. A quick reminder that we are streaming this conversation to YouTube live, so you're able to share it with friends and colleagues after the fact. We're ready to roll here with our host, Patrick Leroux, Associate Dean of Research in the Faculty of Arts and Science. So I'll be passing it off to Patrick and his special guest so that we might learn more about organic contaminants. Exciting. Hi, Patrick.
Hi, thank you, Anna. It's really a pleasure to continue our day of science with our colleague Xianming Zhang, from the Department of Chemistry and Biochemistry. I'll introduce him briefly, and then we'll dive in. Dr. Zhang is interested in environmental chemistry, in the chemical impact and risk assessment, and looking at environmental modeling. So those are the main three themes, but as we'll see, he is involved in so much more. After a BSc in Environmental Sciences from Peking University, MSc in Physical Geography from the University of Toronto, PhD in Chemistry, and eventually a postdoc at Harvard University, where I see you're ranked first nationwide for this competition. So congratulations for that NSERC postdoc a few years ago. Dr. Zhang also worked in industry for a number of years before becoming a professor as a scientific evaluator at the Pest Management and Regulatory Agency of Health Canada, and also a research associate at the Ontario Ministry of the Environment. And he has been with us since May 2021, so very recently, mid-pandemic. Dr. Zhang joined us with great enthusiasm and so many projects. Welcome. I've had the pleasure of visiting your lab earlier this fall. It was, I have to say, very exciting. There were so many things in there. There was a car tire. There were various hoods, and I just sensed that we had entered into a world of possibilities and tinkering, and that you were working on so many things at the same time. Could you maybe summarize what mostly are you working on now?
Yeah, thank you, Patrick, for the introduction. So I'm glad to come here to share my research experience, and over the past 2 years, my experience at Concordia. So you said, my research focus, I'm an environmental chemist, and my research mainly focus on organic chemicals emitted to the environment and to the environmental processes, which include how the chemicals transport from the source regions to the broader environment, including different scales, global scales and regional scales, and also how the chemicals transforms in the environment. Because some of my previous research have suggested that some of the environmental transformation products can pose more risk compared to the chemicals directly emitted to the environment. So that's my focus on the main focus is on the processes, and also some of my previous research also related to the exposures to chemicals by the ecosystems and human exposures from our ambient environments. Mm-hmm. So that's my research focus on that. So currently my research goal is mainly to identify chemicals of potential environmental concerns and characterize these their sources, like transport and transformation processes in the environment. So that's my research goals. All the different individual projects falls under this umbrella.
Okay. Right, and so you're looking at the chemical as contaminants, but also what is contaminating certain chemical configurations. I guess there are 300,000, 350,000 commercial chemicals out there. Where do you start?
Yeah, so as you said, there are a lot of the chemicals produced to serve certain functions of our modern societies.
Right.
Like some used in industry, some used in agriculture. So the modern society cannot go without some of the functions that provided by those chemicals.
Right.
But at the same time, those chemicals inevitably can be released to the environment, and there's a challenge to address such a large number of chemicals in terms of their environmental exposures and risks. So my research tried to address this using from two ends. So one end starting from the chemical inventories, as you mentioned, those industrial chemical inventories. So because over the past decades in the field of environmental chemistry, so scholars through efforts, we have identified certain chemicals of environmental concerns. So one approach I use is based on that, we use the computational model simulations and to link the chemical structures with the potential environmental hazards, and to try to rank those large number of chemicals that's produced and potentially released to the environment. And then that is one approach. Another approach I've been taking is based on the environmental monitoring using the high resolution mass spec and linked with both gas chromatography and liquid chromatography, the most advanced analytical techniques for analyze chemicals in the environment. So by analyzing the different environmental samples, so in each environmental samples we analyze, actually there can be over 10,000 of peaks. Some are unknown, contaminants, some are unknowns. So another approach I take is try to take the information from those instrumental analyses and rank those peaks in terms of their environmental risk, so that we can just identify those chemicals with the potential environmental concerns.
Right. So this is potentially extraordinarily wide-ranging. Can you give us an example? I'm thinking of that tire in your lab. What would you do with that, and how would you analyze this? Because you talked about computer modeling, which I guess is in silo. I forget how you call it, but basically computer modeling from the chemicals that you see, I guess, emanating from the tire. Do you put it in a chamber? Do you let it out in nature? And how do you measure this? And what do you compare it against?
So first, the interest about the vehicle tires is mainly attributed to group of chemicals added as the rubber additives, so mainly to serve the function of the as antioxidants, so protect the rubber from being oxidized by the ambient oxidants. Right. So that's the initiative taking. And 2 years ago, there was studies suggesting some of the chemicals originated from the tires have been suggested highly toxic to aquatic ecosystems. Okay. So, but that was findings mainly related to the toxicity of these chemicals. Right. And for chemicals to pose the toxic effect, so there's a different environmental processes experienced by the chemicals from the source, which is the tire itself, and to the aquatic ecosystems. So currently my main focus is on the atmospheric pathways for these chemicals, which hasn't been well addressed. So if we look at the chemicals starting from the tire itself, so the chemicals added to the materials, so the process involved includes first, the chemicals can diffuse from the bulk materials to the surface, because it is at the surface where the ambient oxidants in the atmosphere in contact with the rubber. So those chemicals added to the tires antioxidants would compete with the rubber material for those oxidants, absorb the oxidants and react it. So after the reaction, so currently in collaboration, with some our collaborators at Environment Canada, we've done chamber testing on the transformation kinetics. So which will help us to characterize the emissions, whether the emissions is the chemicals added to the tires as antioxidants,
right.
or after the reaction, it's emitted to the environment. So, and also like currently, like my research also try to use computational modeling approach to simulate the diffusion, like from the bark material to the surface. And at the surface, the chemicals can diffuse to the atmosphere in the gas phase, and they can also come to the ambient air as the tire wear particles. So those are the different pathways that hasn't been well characterized, that we try to use this integrated approach, combining laboratory experiments, computational modeling to better quantify those processes, which will be helpful for us to understand the emission factors from the tires and linked to the ambient environmental exposures to these chemicals.
And so you use chambers to measure this, I guess, to have the conditions absolutely controlled. Do you also have the in silico, as we mentioned, the computer generated models? You also have in situ, like just measuring the tire in a natural space, or is that impossible because of constant changing variables?
Well, that is a bit difficult to measure the tires in situ. So I've been thinking about that direction. But currently there's some I think we start from the simple under laboratory conditions, because under the real environmental conditions, there are like different oxidants, and so that is in order to just address the certain scientific questions related to these processes. So we will start from the laboratory controlled conditions. So once we understand these individual processes, we can link to the actual real world environmental conditions.
And you mentioned so various chemicals are added as antioxidants to the tires in this case, and I'll stay with the tire because we've got a concrete object here. Are those man-made, anthropogenic, or are they natural? And I guess a follow-up question might be: are we seeing the anthropogenic chemicals being worse for our health, more nefarious, or does it not really matter?
Well, there are a lot of the anthropogenic chemicals have been suggested pose a health risk, over the past 2 or 3 decades. So
that is something we're seeing, yeah.
Yes. So in the old days, 30 years ago, when the knowledge in environmental chemistry, environmental toxicity is not so well developed, so at that time, a lot of chemicals produced, a good example, well-known example is the DDT, the organochlorine pesticides. So they're can have been posing a lot of environmental health impact. So those chemicals are what's so-called persistent organic pollutants. They're very stable in the environment and are not, and they can accumulate to the food chains. So, So currently, based on over the past decades of the development, in the understanding on the link between the chemical structures and their environmental persistence and bioaccumulation potentials. So currently, through before productions, we can evaluate whether molecule is likely to have such properties. So that through the computational chemistry, and also through some laboratory testing, so that is now I don't think because of this knowledge, so there's less likelihood for the industry to come up with those highly persistent toxic chemicals like DDT. But that doesn't mean that the chemistry, the environmental impact of all the chemicals produced has been eliminated. So there are a lot of the new chemicals, and they're producing large quantities that have been each year the community of environmental chemistry have identified some chemicals that are causing potential environmental concerns.
Right. And so the elegant chemical solutions we found in the past are turning out to be a bit more complex than we expected, and you're looking into this. You alluded just now to some chemicals of concern that are emerging. Could you tell us about some of them that you're discovering and that you're interested in researching?
So chemical concerns, what I mean, like the community mean, like chemical of environmental concerns means that they are very highly stable in the environment, so not subject to like environmental degradation, and that they can like have a high mobility. So that means they can spread out from the source and to the like a larger scale, like the environment. And also they can bioaccumulate like to the food web, including to the human body, and also the posing toxic effect. So those like indicators are linked to what we used to tell like if a chemicals is an environmental concerns. So my research, because like I started screened like the industry chemical inventories and also identify some chemicals that produced in certain parts of the world, like so that can have the structure similar to what we know that cause the environmental concerns. So that is one area like my research focusing on the chemical inventories. And another, but the chemical inventory does not include the potential transformation products of those chemicals that potentially release to the environment. So another part of my work is to try to identify some potential like transformation products through monitoring the environment, like in the air and water. Like we take samples and analyze those samples and try to find like if there are some chemicals like we don't know that does not appear like in the chemical inventory, which can be the transformation products of those chemicals that may cause like environmental concerns.
And will you follow one or a certain set of chemicals throughout its various permutations, air, the water treatment route, the agriculture, the food? How do you follow that in your research, or do you focus on one particular aspect?
Well, like normally, like we start looking at the environmental monitoring data. So currently, since the 2 years ago, when I came to Concordia, we have done some analysis for the ambient air samples and also the surface water samples. So as I mentioned earlier, like in each sample, there are like over 10,000 of peaks that for us to evaluate. So we were using the different approach, try to like rank those peaks in terms related to their potential environmental risk. And and we're trying to, we have identify some of the chemicals, like it can be some of the potential transformation products of the chemicals widely used. So one example, like currently an undergrad students, like based on the monitoring results, we found some of the high abundance of some chemicals in the environment. So we raised our proposed the hypothesis that for the origin of that chemicals, like we thought it's from transformations, like with the chemicals in the ambient environment. So the students like is doing like the controlled laboratory studies to look at the transformation pathways and to prove that transformation can actually happen like under laboratory conditions, and then like we will evaluate the ambient environmental conditions to.
Right. So this is the next step. You're not doing that yet. Right?
That's right.
Okay. Because I was wondering, how do you identify which samples to actually analyze, and do you focus on certain chemicals per se, or chemicals within the environment? And which environments would you be interested in studying?
Well, so currently my main focus right now like is on urban environments. So because like
Montreal.
Well, it's not restricted to certain locations, but in general, the urban environment, because the urban environment, so in the world, like over 50% of the global population live in the urban environment. And a lot of the materials used like in the urban environment, so which means that a lot of the chemicals emitted like in the urban area. So from, for example, the traffic and also from the the high-rise condos, the materials used there, and some of the also a lot of the chemicals used as the personal care products get down to the sink and get to the wastewater treatment plants. So those my focus. So there are chemicals emitted to the air and also emitted to the ambient water through the wastewater effluent and also through the urban runoff. So especially now is at the snow melting season. So currently one of my focus is on the snow, because over the whole winter, the snow, you can see some snow packets looks very black, they're black particles. Yeah, so we have taken samples on the snow and mainly to try to trace the chemicals and see whether the snow melting will release some of the chemicals we are interested in, such as the tire wear chemicals to the ambient environment during the snow melting season.
Right, because I guess the chemicals are captured in the snow, released partially over time, and you can actually measure that release, I guess.
That's right. So we try to see at different time periods, over the winter, whether that the chemicals accumulate in the aged snow, because the melting it's in the springtime, it's within a short period. So if there's chemicals, a lot of chemicals have accumulate in the snow, that means there will be a pause for the chemicals released to the ambient aquatic environment. So that is currently we're trying to measure, to estimate, by taking samples around the city, we try to estimate for city with a given population, with the given traffic densities, what would be the release for the certain chemicals we're interested in.
Right. And you really, I'm getting a sense that you have a very clear overview of the place of chemicals in society and in the world, from its origins, its transformations, its unexpected results, all the way through the various streams, if I can use an image, through the food stream, but through plastics, through our lived experience. It's too much to do alone. How do you reach out to collaborators, and who are some of the collaborators you're interested in working with, and what fields are they working in?
Yeah, so because environmental chemistry is really interdisciplinary subject. So currently so the key to address some of the questions in scientific questions in environmental chemistry is through integrated approach. So which means for myself, I have expertise on analytical chemistry, so using the chromatography mass spec to analyze organic chemicals, and I'll also have some expertise on the computational modeling. So, but currently, so I'm trying to because my research mainly focus on the processes involving within the different environmental media, but for chemicals to pose risk. It's the toxicity is is an important factor. Because of chemicals, there can pose different toxic effects through different modes of actions. So that is not beyond an area beyond my expertise. So I tend to seek collaborations in that area, related to how the toxicity and related to the environmental processes which contribute to the environmental risk of chemicals. And another area, so currently I'm also collaborating with scholars in our Center for Center of Research in Molecular Modeling. So CERMs, CERM, yeah. So that's so through collaboration with the GEOs, we're trying to look at the specific transformation pathways using the quantum chemistry approach. Okay. So to evaluate whether some potential transformation products are likely to form under ambient environmental conditions and pose potential environmental or health impact. So that's the areas I'm expanding my research into through the collaborations, and also And also like besides like internal collaborations, I also like collaborate with scholars like at Environment and Climate Change Canada.
Right.
So to like through, for example, using some of the chamber experiment to study the chemical transformations there, and also analyze samples through the existing environmental monitoring network, like that's led by scholars like and collaborators at the Environment and Climate Change Canada.
Okay, and I noticed that you also have a cross appointment in geography, planning, and environment. What does that mean exactly? And what possibilities of interactions, conversations, and research interactions does this open up?
Yeah, so I got cross-appointed to, I applied for the cross-appointment in geography because in my research, I use a lot of the techniques, approaches used in like a physical geography. For example, I use the GIS to try to link the environmental monitoring results or computational modeling results, like on the large scales to like a land use or point sources, which can be like the GIS. So geospatial information system would give a very helpful approach to address some of the questions to look for the sources of certain chemicals.
Right. So the students have that expertise. Do you have students across departments, in both departments? How does that work? Do you bring them into a lab out at Loyola in chemistry, or do you have two teams working simultaneously?
Well, since I just joined the geography like 2 months ago, so I haven't yet. Okay. So, but like in the future, like that, some students mainly focus on the linked with the geospatial data and the environmental monitoring results. So that's the students. They will be like recruited from the geography and planning, and also like another aims for the involvement with the cross appointment in geography is to like establish collaborations with the scholars in the field of the like urban planning, like physical geography, so that is. Because environmental science, environmental chemistry is related to the geology and hydrology, so it's an interdisciplinary subject. So there's through the cross appointments, I found there's a potential, opens a lot of potentials for collaborations, by putting expertise together to address the scientific questions.
It's fascinating. This is something you asked for. You saw this opportunity, and you can see this as being absolutely complementary to your research program. And the way you frame it, we can see the research for the next 10 years mapping itself out. What are some of the big projects you're interested in now? Where do you want to place your energy?
Well, so currently I'm very interested in the transformation products of some of the well-known. So one goal is that through some transformations produce the new chemicals that can cause higher risk. So, and on the other hand, some of the transformations can produce the chemicals like we know well, like as a secondary source. So that are two areas like I'm putting some of the efforts in, so to that, what can we through the integrated approach, try to better characterize the variety of environmental transformations and identify the most important environmental transformations in terms of their forming the secondary contaminants that pose elevated environmental risk. So that is one area I want to expand my efforts into that.
And is there one contaminant that is especially of concern to you, that you feel we absolutely need to focus on this?
Well, the chemicals, that is the chemicals I worked before. So currently, it's a perfluoro eco substances. So that is the chemicals called forever chemicals, like because they're in the under natural environmental conditions,
right.
like no degradations occurs like in the ambient environment. So a lot of the chemicals being released, being used, like and for some of the most toxic compounds, like with the name the PFAS. So that has been banned, like the source have been eliminated in North America, like for almost 20 years. But we still see a lot of those chemicals, like in the ambient environment. Yeah. So that is one pathways for those chemicals to show up, like in the environmental media, like through the transformation, some of the precursor compounds, which hasn't been well addressed earlier, that can act as a secondary source to that chemicals. So that is the chemicals of a special concerns right now.
Okay, so that's daunting, the forever chemicals. So we have to find solutions for this, right? We've produced them, we've liberated them, and they're there forever. Are there ways to counter this? Are there ways by using chemistry against those forever chemicals that we can address this? Is this even possible?
Well, to address, because that is just one of such chemicals. Right. Like in our daily life, we're facing a lot of the chemicals that people have raised concerns about their potential environmental risk. So the way to address is through the working together between the academia, the different stakeholders, like for example, the science, driven. For example, in my research and in the research in environmental chemistry, so the scholar identify the issues of the certain chemicals and then influence the policy making and also interact with the industry, switching to alternative of the chemicals. So that is the current approach, that has been, we have been taking, the society have been taking to address some of the issues. But there's also some limitations in that approach, because first, for the science, to get in the scientific knowledge for certain compounds and their environmental processes and risk, it takes time.
Right.
And also for the regulations, and takes time, and also the industry, sometimes they tend to when one chemicals is banned, they will tend to switch to alternatives. But the alternatives, and a lot of the cases, the alternatives to replace some of the chemicals produced known to have the environmental risk is not that better compared to but we're facing just this endless loop, so that's, I think that to better address these issues is to as one of the UN Sustainable Development Goals suggests the collaboration. So that is the partnership between the different stakeholders, in academia, in the government and industry. Only if the different stakeholder work together, I think can these problems be solved quickly, in the timely fashion, to reduce the potential exposures of the toxic chemicals by the general public.
Absolutely. And you've had this experience in government, both provincially and federally. So you see how it works there and what they're receptive to in terms of the science. Have you engaged with industry in the same type of way yet?
Well, currently, I don't have direct interaction with the industry, so only through some exchange with the opinion exchange. Yeah. So, but that is also the one area. So aims to expand, to make the connections and work on the areas of common interest, because the industry also really need to put a lot of attention to potential environmental hazard and risk of the product they produced, because it would influence the profit. It's related to the depends on if it's regulated, that they have to find alternatives to as a replacement for their products serving certain functions. So that they also have as I know, they have normally those big chemical manufacturers, they have branches doing like environmental chemistry study and toxicity, there's a potential to establish collaborations there.
I was, as I was reading through your research and summaries, obviously, I was curious to know how you teach and what you teach, who you teach to, especially since you're both in chemistry, biochemistry, and geography, planning and environment. And I noticed you had developed this course called Chem 283, Air, Water, and Soil Processes. And as I started reading the description, I thought, this is like the everything class. It's environmental chemistry writ large. Can you tell us a bit about that and what impact this has on the students as well?
Yeah, so that Chem 283, it's called Air, Water, Soil Processes. Basically, it's an introduction to environmental chemistry for the environmental science and sustainability programs. So that course actually was originally developed by Dr. Greg Koss. And I just currently I'm continually updating that to the and I'm also taking the responsibility of delivering that course. So I really enjoyed teaching that course because we touch a lot of different areas in environmental chemistry related to the students' daily life. So for example, we talk about the air pollutions in urban areas, so which can be linked to some of the news articles related to the air pollution events. So when there's air pollutions exceeding certain threshold, the Montreal will issue certain guidelines for the for example stop wood burning stove, that type of related to their daily life. And last summer I also worked with the students in that class and also graduate students. So this is an initiative a start with Center for Teaching and Learning at Concordia Universities. It's called Sustainability Co-Design Project. So the idea is by through the partnership between the instructor, the students, and also the professionals at the Center for Teaching and Learning. So we try to enhance the sustainability components in the class. Okay. So we take different strategies. One strategy is to link the topics that I am teaching in this course to their daily life. So currently at the beginning of each lecture, so we always analyze news articles over the past very recent news articles. So for example, this semester we touch about the chemicals that release due to the train derailment in the Ohio, so whether it's concerns, what concerns can come from, and also some of the chemicals recently detected in our toilet paper. So we all discuss the topics that are related to their their daily life, the news they will see or listen, and also some of the products they use in their daily life through this approach. So I think it would be effective to link the contents of this course to the sustainability development goals and to enhance the students knowledge in the sustainability development goal.
And I guess you get interesting questions and concerns from the students in this course, but also throughout your various courses and seminars. What are the principal concerns that come up? What questions are your students asking you to dive into with that?
Oh, well, so for example, recently we talk about the disinfection process for drinking water. So because of the some of the disinfection for drinking water using chlorine, so the chlorine can form a lot of the chlorinated compounds as a disinfection byproducts. So some of those disinfection byproducts can be health concerns. So we're talking about that. So the students becomes worried, or curious on what they can do to reduce exposures to those disinfection byproduct in drinking water that's in which the treatment is using the chlorine for the treatment.
Okay. And does this create some eco-anxiety in students?
No. I try to all the topics, because it's a science course. I always highlight that it's all the topics have to be science-based. So we talk about the science behind that. So all the risk comes from the exposures and toxicity. So for that, it's not. I'm not trying to just give the students the science backgrounds behind those topics. We don't touch whether I don't want, that is not my goal to give the students the anxiety for that issue. We also in contrast, we actually analyze some of the news article that sort of exaggerate on certain environmental issues. We talk about the science behind that, and whether so in the end the students understand why that some news articles is sort of exaggerate the concerns of the certain environmental issues.
Right. So you're giving the students tools to basically understand, analyze, and eventually your chemistry students find solutions.
That's the goals for that's my teaching goals, is to let the students have enough science scientific knowledge, and to tell because there's so much information they come across in the news media, in their social media. Some are not the science behind some of the information is incorrect. So my goal is to let the students have this fundamental science related to the environmental chemistry, so that they can tell and make correct correctly interpret the information they come across.
This has been a great introduction to the world of environmental chemistry. Zhang, you've really given us a lot to think about. I'm now acutely aware of how I'm breathing and every chemical in this room, but not too nervous about it, because I know people like you and your students and your colleagues are looking into this. You've been here 2 years, almost 2 years at Concordia, and already you've done so much. This is very exciting work, and thanks for sharing this with us.
Thank you.
If you have an idea for a podcast, please let us know. You can contact us by email at info.4@concordia.ca or find us on social media at CU Fourth Space. All social media is managed by Jacqueline Wexler. This episode of the Fourth Space podcast is hosted by me, Maximus Delmar, and produced by Anna Voklavek and Douglas Moffat. Editing by myself, Douglas Moffat, and Chanel Lees Marshall. Additional thanks to Supercontinent for providing our theme music. Thanks for listening.